Hello everyone, here we are at Thingvellir Rift. Behind us you can see a wonderful escarpment, and that is the easternmost edge of the North American lithospheric plate. So you're probably all familiar with the idea of lithospheric plates and continental drift. The Earth's crust is composed of 6 or 7 major lithospheric plates and any number of minor plates. And these are moving around the surface of the Earth, making the continents drift due to processes of convection and subduction within the plastic rocks of the mantle. So in the 1950s, after World War II, there were various bathymetric surveys happening of the North Atlantic Ocean, and they noticed this submarine ridge of mountains beneath the ocean, and this was really the kind of final bit of evidence needed to prove the theory of continental drift. And this point, well, Iceland is really the only place in the world that you can see the edge of the North American plate exposed above the surface. That's what we can see there. And under the surface of our feet is new land. So the Eurasian plate moving east is tens of kilometers behind us to the east. And this here is new continental crust that's being created and erupted over about 24 million years since Iceland first began to form. So the engine behind continental drift, you might think, oh well, that's a bit disappointing. I wanted to stand with one leg on the North American plate and one leg on the Eurasian plate and have a river of lava between my feet. But unfortunately, it's not quite that simple. The fracture zone where Iceland is spreading is quite complex. We've got a western fracture zone that we're in here, and the eastern fracture zone is some hundreds of kilometers in that direction. But one thing you do get in divergent plate margins, constructive plate margins, is lakes. Because as the two continental plates pull apart, you get subsidence of the land in the middle. So behind us we have Thingvellir Lake. The parallel with that is the lakes in East Africa in the rift valleys. So that's the context to where we are. Any questions?
How fast is it growing?
Good question. So the plates are pulling apart at a rate of 1 to 2 centimetres per year, which is apparently, I've never checked, about as fast as your fingernails grow. So last August we had an eruption of Bardarbunga volcano, which is to our northeast, and when that volcano was erupting, the plates there was crustal extension of about 20 centimetres per year, so much accelerated.
We were having that conversation on, I don't know what day it was, but about whether it is just going to split or whether it's going to keep growing.
It's a good question. So because you've got this upwelling of magma when the plates are extending, we're creating new continental material. So they're not going to split. Iceland won't become 2 islands, but it will become bigger and bigger. It's hard to model exactly what will happen, but if you go back in time sort of many hundreds of millions of years, all the continents of the Earth looked very different, and they were assembled into one supercontinent called Gondwana land. Prior to that, they'd split apart and reassembled into Pangaea. So there are these various cycles of continental drift and coalescence. In fact, Iceland is part of the same volcanic province as the east coast of North America and the mountains of Scotland.
So what's happening on the other side of the North American plate? So this is moving that way. What's happening on the other side?
Well, if you go all the way to the east coast of America, you've got a transform margin, so that's where 2 continental plates are sliding against each other down the San Andreas Fault, which is why California is so much at risk of earthquakes. And if you go east, you've got the Eurasian plate being subducted beneath another lithospheric plate. That's why you have the Himalayas, this huge thickness very high mountains, as the crust piles together. And you also have the Pacific Ring of Fire, all the volcanoes that have formed, Japan, the Philippines. That's the result of a continental lithospheric plate being subducted beneath the Pacific Oceanic plate.
Hi, Dr. D.
Hi.
Geology, rocks, apparently. Textbooks tell us that the convection currents in the mantle sort of come up and they push the plates apart, and we have magma coming up forming new plates. So this is the North American plate, yes?
Correct.
It's moving that way.
Yes.
We've got the Eurasian plate about 60 kilometres over there, and it's moving that way. Where's the magma? Where's all this stuff that we see in textbooks?
Well, the textbooks are a bit of a oversimplification. They're good for understanding the basic processes, but in reality, continents splitting apart and creating new continental crust is a messier, more complex situation. So if our glamorous camera lady looks over here, we've been talking about this as the edge of the North American plate, but you might be able to see in the far distance that there's clearly a bit of terrain, an escarpment to the left, to the east, which is clearly the same formation, and they've probably fractured apart in an earthquake. What we've got in Iceland is a zone several hundred kilometres wide where we've got fracturing of the plates, lava going one way when there's eruption, lava going another way at another time, upwelling of magma. So it's a bit more complex. The reason why we haven't constantly got magma bubbling away in the middle is that the engine behind continental drift is really the subduction margins on the other side of the plates. So far to our east, where the Eurasian plate is getting subducted beneath the Pacific plate, you've got this continental crust, brittle, being dragged down towards the mantle where it gets remelted. This is more passive, so the plates are spreading apart. There'll be earthquakes, there will be eruptions, but they're spread over a large area and they're by no means constant. You have a volcanic eruption in Iceland, a major one, on average once every 5 years. The last was in Bardarbunga, finished in March this year. That's to our northeast, and that erupted about 15 cubic kilometres, I believe, of new magma, new lava, new continental crust, new crust if you will, but it's not happening everywhere within Iceland, within the rift at the same time.
Is Bardarbunga on the fault line?
It's within the spreading zone, but as I explained, it's not quite as simple to define a single fault line which you can point at and look at.
Okay.
Thank you very much.